Okay, everything we do is available on BioniChaos.com. Go check it out. Hey, provide your comments, feedback, whatever tools you tried. Take whatever print screens, video recorded yourself using it, and send it to us. Let us know how it goes. I will be jumping into Lilac. Yeah, so essentially redoing all the pages. We're currently about 50% through. How many pages do we have on this site? Gazillion. We have 268 pages, and currently we're still going through 126 pages with some issues in them. So just take this one for example. It's the old style, how it was developed whatever a couple of years ago, about a year ago. Does the HTML have a date? Yeah, 2025, mid 2025. So we'll be redeveloping, and we are testing Quen. So one of those Chinese models. It's currently it's Quen 3.8 Max, whatever that means, and just read its thinking and search and see what the new version of it looks like. So hopefully that makes any sense.
Refining the illusion simulator with enhanced visual fidelity and interactive responsiveness. I am reimagining the core structure to ensure seamless animation and precise perceptual effects. Attention is given to optimizing performance while preserving the subtle nuances of the afterimage phenomenon. Each element is carefully calibrated to deepen immersion and align with the psychological essence of the illusion. Enhancing content depth and structural integrity. I am enriching the existing material by expanding its narrative scope and factual richness to meet recommended word count standards, ensuring a more comprehensive and engaging reader experience. I am integrating essential metadata and canonical references to strengthen search visibility and establish content authenticity. I am refining the layout with strategic exclusions for ad interference and optimizing rendering performance, presenting a cohesive, responsive interface with refined visual and interactive integrity. I am orchestrating a seamless user experience through deliberate layout precision and adaptive design, ensuring clarity across devices while maintaining aesthetic consistency with a dark, grid-based visual language. I prioritize intuitive navigation and tactile feedback, embedding responsive interactions that respect touch dynamics and preserve system stability. I guide attention through structured content hierarchy and intelligent contextual linking, while safeguarding ad placement and...
Yeah, obviously that's a lot of nonsense. I kind of missed the main point is the colors. The illusion actually have disappeared because it stuffed up the colors. So that's actually prompted once. I'm surprised because this is meant to be a super powerful model. Okay, it seems like we actually stuffed up the colors. Well, you did. The colors are important for the illusion to actually work. Currently, the illusion isn't working. Pay attention to the background color, would you? Okay, I like the text to speech in Quen.ai. It's working well. Yeah, so these colors are absolutely crucial for the illusion to actually work. Yeah, well, otherwise I did everything well, except I think I got confused a bit probably by the instructions. Get confused. Yeah, eventually everything we do is available on BioniChaos.com. This one is BioniChaos.com/LilacChaser. It's an actual thing, actual illusion. And go check it out. Okay, it's thinking quite a bit.
adjusting the color scheme to match the lilac chaser illusion's requirements. I recognize the need to correct the hues used in the visual representation to align with the perceptual effect of the illusion.
That's right.
The previous colors disrupted the intended afterimage phenomenon, so I am recalibrating them for accurate execution.
Okay.
This ensures the dynamic disappearance of the central dot is preserved through proper chromatic contrast. Ensure the background is a neutral gray for optimal effect. I am focusing on the critical role of background color in sustaining the illusion's effectiveness. A dark or black background disrupts the visual balance needed for the phenomenon to emerge. Maintaining a uniform, mid-tone gray preserves the delicate interplay that makes the afterimage visible. Maintaining optimal visual conditions for perceptual phenomena.
Yeah, kind of
The
surprised
luminance
you didn't get
contrast
it
must be balanced to
already
allow
in the
proper
first
afterimage
place.
formation and effective Troxler fading. Soft, pale hues in the peripheral stimuli create a subtle visual field that dissolves when fixated upon. As attention remains fixed, the mind fills the void with complementary colors, producing an illusory motion of green hue around the circle. Adjust the visual design to align with psychophysical principles. I recognize that the original aesthetic compromises the illusion's effectiveness, so I prioritize perceptual accuracy over stylistic consistency. By refining the color scheme, using gray for the background and soft lilac for the discs, I ensure the contrast supports the intended visual effect. The interface retains its functional dark HUD, preserving usability while enhancing the illusion's credibility. Render the final output with precision and elegance. I am ensuring the HTML structure is fully self-contained, adhering to the requested format without deviation. The content reflects a refined technical explanation, integrating subtle corrections for clarity and scientific accuracy.
Yeah, that's fine. It's very verbose, this Quen 3.8. It's going on and on and on forever. It's not lazy. It's an actual thing. This one isn't lazy, so it generated a lot of clinical raw mouth feature direction, blah blah blah. Yeah, that color space was kind of important. HTML5 canvas. Yes, it knows. Obviously, can do all that. The other thing is the demo mode. I think in our original prompt, the demo is a bit jumpy. The idea for the demo mode was to simulate a user actually sliding the slider, so it meant to be gradual, not jumpy like that. Let's see how we fix that for future development. Okay, this Quen 3.8 thinking is pretty slow. It cannot run the HTML in the browser on the page. Okay. What did you do? I don't know. It's stuffing things up. It's stuffing things up. What you do it there? Why is it grayed out? Why is it grayed out? Quen. Don't understand. Okay, let's go for Gemini 3.7 Flash. 3.7 Flash. We'll have a procedure for this thing. A Flash will do high thinking level. We have the HTML and we have the specification. And yeah, you would expect the flagship model to kind of realize that the color scheme there is absolutely important. And let's see if Gemini 3.7 Flash gets it correctly. It kind of should be obvious without extra prompting that the color is meant to be left intact. color is meant to be left intact. Okay, so it's still okay. It's the initiated branch A. It's fine. That's what's in. That's the options in development prompt.
Initiating branch A. I've initiated branch A, aiming to refactor and enhance the existing codebase, focusing specifically on the Lilac Chaser illusion simulator. My current priority is evaluating the code and aligning it with the prompt specifications for dynamic execution directives. I'm focusing on the first element, evaluating the code at the moment. Updating documentation and rewrite. I'm now deeply engrossed in updating the documentation and rewriting the code for the Lilac Chaser illusion simulator. My focus has shifted toward integrating dense, detailed explanations into the documentation panels, incorporating k-tex equations and relevant terminology from diverse fields. I am committed to a performance-optimized rewrite, with an emphasis on responsiveness and mobile compatibility. Defining metastructure and CSS. I'm now implementing the metastructure and site-wide CSS rules. I'm focusing on those specific meta tags and canonical URLs. I'm working with the exact corporate color variables and the responsive layout definitions for desktop and mobile environments. This includes detailed specifications for the canvas wrappers and styling the high-tech HUD panels with interactive elements. Implementing HUD and layout. I'm now implementing crucial HUD elements and refining the single-page layout. I've integrated data Google Auto Ads equals none to exclude ads from specific areas. My focus is on the required body markup, particularly the standard navigation and side-by-side action buttons for Start Demo and Reset Baseline. I'm also addressing the demo mode indication, including the sound toggle button. Finally, the interactive laboratory canvas featuring the Lilac Chaser illusion is coming along well. Refining simulation parameters. I'm now integrating an array of adjustable parameters to refine the Lilac Chaser illusion simulation. This includes controls for disk radius and count, gap rotation speed, and blur. I'm also adding hue, saturation, and luminance controls with custom color pickers. Further, I'm incorporating fixation cross styles, motion modes, and real-time retinal cone bleaching and neural response visualizations, with interactive controls to position the ring and the fixation cross. I'm focusing on dynamic real-time diagnostic readouts.
Okay, Gemini 3.7 Flash went out to town. Not sure what is the point of adding different chromatic channel schemes, because the lilac thing just works. And that's the default. Well, the default, at least for me, is not optimizing for seeing the illusion. And whatever percent of people don't see it at all, I think there should be an explanation about it. I do see the illusion with these settings. Okay, just a couple of things. First of all, can you take the settings from the image and make these parameters default on page load? Second thing, in the description somewhere we meant to describe there meant to be a mention of essentially what do we do to the parameters, how do we change the parameters so we optimize the illusion effect for us, for a specific user. So I'm not sure if it's currently there. Can we check? Okay, and the last point is that the demo mode, well, first of all, if we're changing any sliders, it meant to be gradual, so it meant to mimic how a user would slide the sliders. So maybe we can make the demo mode better. Yeah, I was not sure about the different color schemes. I ignored my second point.
Analyzing image settings. I'm currently focused on extracting settings directly from the provided image. My primary goal is to identify parameters like step interval, speed, and translate them into usable default values. This initial extraction phase is crucial, as it sets the foundation for dynamically configuring the interface. I'm taking a close look at the details in the screenshot now. Extracting parameter values. I've successfully extracted specific parameter values like 190 milliseconds, 19 radial disks, 46 px disk diameter, and 130 px orbit eccentricity. I'm also noting the color scheme, luminance contrasts, and background luminance values, which are key for default UI configurations. Now I'm carefully reviewing the latex-like labels for precise variable extraction and improved rendering on the canvas context, such as $P_L, T, $. Refining default parameter sets. I'm now integrating the extracted parameter values to refine the default settings. Specifically, I'm working to translate values like step interval, num disks, disk radius, ring radius, and blur radius into robust initial values. I'm also addressing the chroma scheme and other UI elements to refine a seamless user experience. Currently working on a smooth interpolation for the demo mode. Orchestrating demo mode. I'm architecting the intelligent demo mode orchestrator. The core concept is a multi-stage continuous scripted journey to showcase the illusion. I've broken down each phase, starting with a baseline fixation phase, followed by Gaussian softening and Troxler acceleration, stroboscopic velocity shifts, and a disk density sweep. Finally, chromatic cycling highlights color opponent pathways and rebound colors. I'm focusing on smooth transitions. Implementing demo mode transitions. I'm now deep in implementing smooth transitions for the demo mode. I'm focusing on color interpolation using continuous easing functions. Sliders will move fluidly with each frame. A key detail: any user interaction instantly halts the demo and preserves the baseline state. This is an exciting step. I'm also ensuring all strict requirements are addressed. Canonical URLs, date handling, KTeX integration are all on my mind. Finalizing the UI. I'm now putting the finishing touches on the user interface and incorporating several improvements. I've ensured KTeX renders correctly without spacing issues and implemented clean Unicode for Canvas oscilloscope text, avoiding raw latex. I've also addressed responsiveness with desktop and mobile layouts, optimized canvas scaling, and arranged action buttons for intuitive access. Anti-collapse rules, touch target sizes, and documentation panel are added to improve usability. I'm also addressing cross-linking and lazy-loaded AdSense integration. Calculating demo math. I'm now refining the math behind the smooth demo mode. I'm tracking demo time and have created a script timeline using easing curves to calculate target values for various parameters like blur, speed, number of disks, and radii. I am also planning on updating the chroma scheme. My focus is on blending current values toward these targets each frame.
Yeah, there's obviously a couple of things that could be improved, but like Jason. Actually deploy quickly. I have a bunch of data sets as part of the project. To go over, probably have to get rid of them or something. Okay, I'm still 123. Sometimes I have to deploy twice. 123. 121, okay. So we're like at 45%. So this should be updated. That should be updated. Yeah, this is kind of optimized setting for me. So with these settings, I can see the illusion pretty well. I don't know why there's so much maths in the text. Too much maths in the text. The backend motion. Okay, we'll look at this MRI synthetic brain generator. We'll do a comparison between, so we'll try and improve it. We have this new prompt. And we'll compare Gemini 3.7 Flash and an old Flash model. Let's go for 3.5. Yeah, we'll do 3.5 and 3.7 Flash. MRI synth. You can check out the current version before it goes away. Okay, we have it was developed about over a year ago. So it's time for an upgrade. MRI synth, yeah, that's correct HTML. And we have up front, and we're comparing. Oh, the other thing is, let's do thinking level high for both models because we have time. So Gemini 3.7 and 3.5 Flash. Yeah, let's run this. I will compare them side by side, see what we get. See what we get. Okay, 3.7 is quicker.
Analyzing the existing code. Okay, I've started delving into the MRI synthetic brain generator applications code. My focus is on understanding its current structure and identifying areas ripe for refactoring. I'm taking notes on potential improvements to enhance its efficiency and maintainability. Implementing the structure. I've been working on integrating the site-wide elements, including the navigation, styles, and layouts. The documentation panels are taking shape, incorporating in-depth technical details with latex formulas. I've also established the CO and meta tags, complete with keyword velocity and relevant attributes. Developing the demo mode. I'm now fully immersed in developing the demo mode functionality. I've successfully implemented single-point activation and state isolation using structured clone. The plane cycling, slice sweeping, and contrast weighting toggling are all progressing well. Adding pathology demonstrations and multiplanar inspection is next. I am also working on interactive stopping and UI updates. Adding sound effects. Okay, I'm now integrating those crucial auditory cues, GX, GY, GZ chirp and pulse sounds, and diagnostic clicks. These will trigger when the user scrolls through slices or scans within demo mode. I'm also ensuring the documentation panels in the footer, which are nearly complete, include over 1,200 detailed words spanning biophysics, practical usage, and technical generation. Expanding the model. I'm now expanding the modeling capabilities, focusing on 3D multi-octave perturbation and tissue classification matrices. I'm incorporating synthetic MRI signal equations for spin echo and inversion recovery. The high DPI canvas buffer pipeline is under development, and I am also optimizing performance using typed arrays and web audio for gradient pulse synthesis. I'm also planning collision-free event architectures. Defining the parameters. I'm now zeroing in on defining all the parameters needed for the procedural generation algorithm. It needs to be fast, detailed, and anatomically accurate, supporting multiple contrasts, window, level adjustments, and slice scrolling. I'm considering using UN8 array or float32 array for efficient volumetric data storage. I'm also planning the voxel parameters, including tissue types like hair, skull, scalp, CSF, and gray, white matter, with associated T1, T2, and PD values. I'm implementing a Patreon bypass check for advanced features. Modeling tissue contrasts. I'm now implementing tissue-specific parameters within the procedural generation algorithm, with a focus on defining their MRI contrasts. I am incorporating values for T1, T1, comma, T2, T2, and proton density.
I guess we have two versions. We'll have to choose between them. We will have to choose between them. Yeah, so Gemini 3.5 Flash is actually like less creative. It did the work to specifications, but it essentially kept the actual models as they were in the original version. Whereas 3.7 Flash was more creative. So what's that line in the middle? What? Doesn't look great. So what that line in the middle is meant to be the line between the two hemispheres, because that looks horrendous. It's pretty bad. And that's the original thing. So yeah, 3.5 Flash just stuck to the original. Which I kind of like better. It's simpler. Yeah, 3.7 Flash just over-engineered some stuff. There's too many problems with it. So we will get rid of it. We'll get rid of that. And we'll keep this as our main thing. Yeah, so generally, Gemini 3.7 Flash seem to be much more creative, and we don't really like it. We like it to stick to the question at hand. So let's do 3.5 Flash again. Yeah, we're having this problem with the samurai synth. We don't need URL context. Does not appear in or imaging. We want to do this a double category. Please explain first. Don't modify the code yet. Thinking level medium should be fine. Yeah, we want some tools to have multiple categories. Okay, can you explain language only, text only, without any code? How do we fix the code for it to work? So the MRI synth appears in both neurology and imaging categories. Just explain, don't generate the code yet.
To allow a tool to appear in multiple categories, such as both neurology and imaging, we need to change how the website processes the category text. Right now, the website reads neurology, imaging as one single category. To fix this, we must instruct the website to split the text wherever there is a comma. Instead of seeing neurology, imaging as a single label, the browser should split it into a list of individual labels, neurology, imaging. Clean up extra spaces. Any accidental spaces around the words, like the space before imaging, should be trimmed off. Build the drop-down list using individual categories. When building the filter menu, the website should add neurology and imaging as separate options, rather than adding a combined option called neurology. To implement this change, you will need to update two functions in the less than script greater than block of your HTML. This updated version splits the categories on commas so that they populate in the drop-down menu as separate, individual options. Find the part of filter content that handles category matching and update the else block to check if the selected category is included in the items list of split categories.
Okay, can you rewrite the two necessary functions as they should be with the updated version, with the changes as discussed? Could have fixed the first one, but the second one is pending.
Below are the rewritten versions of both functions, incorporating the comma splitting and whitespace trimming logic. You can replace your existing getAvailable categories and filter content functions in the pages less than script greater than section with these updated versions.
Okay, let's redeploy and check so everything is working. Okay, so we have that, we have this. Neurology. Seem to be only appearing in imaging but not neurology. Okay, currently it does appear in imaging category, but not in neurology. Can you explain without modifying anything, without any code generation? Just explain what's happening. Still trusting Gemini 3.5 Flash. A medium thinking level, so it should be fairly quick.
I'm currently reviewing the input files the user provided. Specifically, I'm examining the index page of BioniChaos. I'm focusing on the... I've located the relevant It contains neurology, imaging. I'm focusing on the category filtering logic, examining the HTML structure. I've scanned the entire HTML file and confirmed the presence of the MRI synthetic brain generator card within the... I noticed there is more than one instance of the card. Now I'm focused on the HTML structure and specifically the data category attribute to understand its role in the filtering logic. Investigating categorization logic. I've been re-examining the category string and checking against the getAvailableCategories function. I've confirmed that the MI_synth item uses neurology, imaging in its data category attribute. Furthermore, I'm now looking closely at the JavaScript, specifically getAvailableCategories, to understand how it handles multi-category entries by splitting the values based on a comma and trimming whitespace. This will help understand how the categories are determined. Analyzing the categorization. I've been looking at the JavaScript functions, especially getAvailableCategories and normalizeCategory, focusing on how they handle and normalize category strings. Based on the source code of your main index page, the unexpected behavior is caused by a syntax error in your HTML structure. There's a duplicate, stray less than lee greater than element appended at the very end of the file, outside of the HTML document. At the very bottom of your main index page, BioniChaos.com, SHTML, the MI_synth card is defined twice.
I'm pretty sure it just hallucinated on me. Let's do thinking level high. Keep the same model. Yeah, that's the tool. It's still working okay. All we're trying to do is have it in two separate categories, neurology and imaging. Yeah, I didn't change anything and said it was correct. Yeah, it's hallucinating on me now. It says why it works now. Well, it doesn't. No, I'm still having the same problem. The tool is working correctly. It is on the landing page, so that seems to be correct. It does appear in the imaging category, but I cannot see it in the neurology category. Can we double check the code? Let's bring the big guns. A Pro version, a Gemini 3.1 Pro. See if we can. I don't know why it's hallucinating. It's like having a very highly talented employee. That's a good thing. We can actually read that employee's mind. Re-examining the logic, verifying the display, investigating the rendering.
I'm now zeroing in on why the MRI synthetic brain generator tool isn't showing up correctly. Even with the search terms as an empty array, the category filter should still show it. I've retraced the logic and compared the data category attribute. I found a huge block of duplicate HTML code, which may contain a critical clue. I'm focusing on the effect on the tool's visibility.
What are you talking about?
I've just been reviewing the code and can confirm my latest findings. I am looking more closely at line 839, which is the MRI synthetic brain generator tool, and how it is affected by the duplicate content I observed. The duplication of this tool, and the code it is in, appears at lines 839 and 1046, and it provides a critical clue to its visibility issue. I'm focusing on why the code is duplicated, and how the duplicates affect what the user sees.
What are you talking about? No, it's out of whack.
Based on the code you provided and the screenshot, the issue is not with your new code. The JavaScript logic you implemented for splitting the categories is 100% correct. The reason you are still seeing this problem is a caching issue. Your web browser, or your server, CDN, like Cloudflare, is still serving the old version of your index, HTML file.
No, it's not. Nonsense. Nonsense. Okay, let's check it in our browser. Okay, imaging. Oops. Okay, we have it in imaging. Neurology. Yes, we have it in neurology. So it is a browser thing. It was correct.
If you look closely at your screenshot, the cards on the very bottom row are EEG hardware and analog front-end, and seizure prediction tech. However, in the HTML code you just shared, those two cards are located near the very top of your document, lines 206 and 269. Because CSS Grid displays elements in the exact order they appear in the DOM, the layout in your screenshot proves that the live website is running a completely different, older HTML file than the one you're editing.
Okay, I'll try deploying again.
You are likely seeing the MRI_SIM card in the imaging category and assuming the new MRI_synth card is working, when in reality, the old JavaScript is keeping MRI_synth hidden from both drop-down filters.
And let's do another tool. And let's search for. Okay, now we do have it twice. Yeah, okay, let's do it again. See if it's actually updating in real time. Yes, it does. Okay, and this tool should be both in data science and vision. So it's in data science and vision. That's correct. And this one should be in imaging and neurology. Imaging. What? Oh, come on. Okay, Control F5 did work. Yeah, funny browser caching stuffing. It's working now. Most of the time we spend on this nonsense. Most of the time we spend on nonsense.
Так, а какого фига у меня все еще этот чел? Этот количество сантиметров у них в заднице.
Right now, inside your web browser, you can actually mathematically grow a human brain.
Yeah, tumors, fluids, all of it.
Right, and without a single drop of real biology.
It's wild. It completely changes how we visualize the human body. I mean,
Yeah.
we're looking at something that turns an everyday screen into a virtual radiology lab.
It really does. So today we are pulling from developer notes and medical engineering papers for a deep dive into the MRI synthetic brain generator.
Right.
And our mission for this deep dive is to see how this tool simulates the incredibly complex biophysics of a magnetic resonance imaging machine, all right in your browser.
Yeah, which is, if you've ever looked at your own MRI results and just seen a bunch of blurry gray blobs,
Yeah.
this essentially gives you the steering wheel to understand what your doctor is actually looking for.
Exact.
And it does that by taking the mystery out of the physics.
Okay, let's unpack this because to understand the simulator, we first need to know what it's trying to replicate, right?
Right.
I mean, standard medical images, like x-rays, they just snap a picture of a broken bone. But MRIs are basically mapping quantum mechanics. It all starts with hydrogen protons, right?
Yeah, they are the absolute stars of the show here.
Yeah.
Human brain tissue is mostly water and fat, meaning it's just packed with hydrogen.
Right.
So when you slide into an MRI tube, a massive static magnetic field, which we call B0, forces all those tiny hydrogen protons to align their magnetic poles.
I always picture this like a stadium full of people all turning to face the main stage.
That is a perfect way to visualize it.
Yeah.
And the MRI machine follows that up by firing radiofrequency, or RF pulses,
Yeah.
into the tissue.
Which is like a sudden massive distraction in the stadium, like maybe a fireworks display goes off in the back and the whole crowd turns to look away from the stage.
Exactly.
They get knocked completely out of phase.
Right, and when that distraction happens, the MRI machine is basically holding a stopwatch. It's measuring what's called relaxation time, which is just how long it takes for the crowd to turn back and face the stage again.
Right.
And that is T1 relaxation. What's really fascinating here is that different tissues relax at distinctly different speeds.
Oh, I see.
So dense white matter in the brain contains a lot of fat, so those protons realign very quickly. That makes white matter appear bright on a standard scan.
But the cerebrospinal fluid, or CSF, that surrounds the brain is heavily water-based. So those protons take a lot longer to turn back around,
Exactly.
which is why that fluid looks dark.
Right. And you also have T2 relaxation, which measures how quickly the protons lose their sync with each other due to local magnetic fluctuations. The simulator computes all these different parameters at every single coordinate point to render the brain slices.
Wow. So that is the actual physics behind it, but I have to push back here.
Sure, go ahead.
If it's this computationally heavy to calculate all those proton relaxation times, why are developers torturing our web browsers with pure math? I mean, why not just upload a 3D scan of an actual real brain and let people click through it?
Well, a static scan is just a frozen snapshot of one specific person's brain.
Right.
The tissue in this simulator isn't a pre-rendered 3D model. It uses mathematical equations, specifically things like 3D fractional Brownian motion over a simplex noise field.
Oh, wow.
Yeah, you can think of it as kind of like mathematical static or turbulence. And it uses that to organically grow the random folded ridges of the brain, the gyri and sulci, rather than drawing them by hand.
Okay, I see.
This mathematical generation allows for infinite biological variability and real-time manipulation. A static image simply can't do that.
But generating a massive 3D volume of math like that, shouldn't that just crash a web browser instantly?
You'd think so, yeah. But instead of forcing your browser to swallow a whole watermelon at once, the software's asynchronous chunking pipeline uses a command called request animation frame.
Oh, okay.
Yeah, it slices the computation into tiny manageable bites. So it renders the brain in microtasks behind the scenes, keeping the visual feed totally smooth so your computer doesn't freeze.
And because this isn't a static photo, you aren't stuck looking at one angle. You can slice the brain open from any direction, axial, coronal, sagittal, and you immediately see how the tissue changes.
Right, and you can toggle resolutions all the way up to 256 cubed. It's high enough to spot incredibly fine detail. The whole interface functions as a fully interactive virtual radiology workstation.
That's incredible.
Yeah, you can even toggle a pathology simulation. With just one click, the math dynamically generates a neoplastic lesion.
Wait, a tumor? So does it just paste a dark circle on the screen?
No, it actually alters the underlying math to create a dense core surrounded by an infiltrative, swollen edematous margin. It behaves exactly how a real tumor infiltrates healthy tissue.
Here's where it gets really interesting, though. They have a feature called acoustic mapping.
Oh, yeah.
You can turn on the audio, and it maps the depth of the brain slice you are viewing to shifting sound pitches.
It's so cool.
Turning those spatial coordinates into shifting audio pitches makes navigating the anatomy this completely immersive, multisensory experience.
It really builds incredible spatial awareness. And the developers are already planning to add more complex modeling,
Oh, really? Like what?
like diffusion tensor imaging or DTI to visualize the brain's white matter tracks, or simulating actual hemodynamic, blood flow and volume changes.
It's amazing. I mean, this whole project demystifies elite medical tech. It turns passive reading about MRI physics into an interactive, hands-on digital dissection that anyone can play with.
Absolutely.
And looking at the source notes, future updates will even include simulating MRI artifacts.
Right, the glitches. Things like motion blur from a patient moving or magnetic field in homogeneity.
Right. So what does this all mean for the future? If these synthetic simulators get so mathematically perfect that they perfectly mimic the physical flaws and human errors of real clinical scans, will the next generation of neurologists be trained entirely on mathematical phantoms that never actually existed?
Okay, let's do this quiz real quick. So question 1, which specific atomic nucleus is primarily responsible for the signal generated in MRI, synthetic brain generator? Well, in MRI in general, due to its abundance in brain tissue. So is it nitrogen, oxygen, carbon? Which one will respond to a magnetic field? So that would be hydrogen, because we know that like water is somewhat magnetic. Human brain tissue is largely composed of water and lipids, both of which are rich in hydrogen protons that align under a magnetic field. Let's do the next question. According to the provided material, why does white matter appear bright on a standard T1 weighted scan? It undergoes the lowest longitudinal relaxation process. The T1 relaxation is governed by the loss of phase coherence. It has high concentration of free water molecules. It contains dense myelinated tracts with high lipid concentration. Why does the white matter appear bright? It's not A. It's not B. It's not C. Yep, D. So it contains dense myelinated tracts with high lipid concentration. High lipid content in myelin results in rapid T1 relaxation times, leading to high signal intensity brightness in this specific imaging sequence. Ooh, there's a mathematical equation. Which equation recall which formula represents an exponential decay of star probability of a starting value rather than a recovery process. Exponential decay. Exponential decay. Phew. That wasn't even a hard quiz. In the slice navigation system, which orthogonal axis is translated when the user navigates through the axial view? So we have the axial view. It's the Z, the Z, if you're American, axis. The axial plane is perpendicular to the Z axis, meaning navigation through different axial slices involves moving along the vertical or the Z dimension. Okay, question 5. How does the MRI synthetic brain generator ensure the web browser rendering thread remains active while generating high resolution volume matrices? Well, first of all, you can do even higher resolution. Not that that makes much difference. This will, by lowering the resolution automatically to 64 cube during every generation. Well, we can actually change that by prefetching pre-rendered biological images from a remote server. We don't have a remote server. We are prefetching by using progressive asynchronous chunking pipeline via request animation frame. This highly technical question is kind of not related to MRI. The simulator uses 3D fractional Brownian motion of a simplex noise field primarily to represent which anatomical feature? The static magnetic field, the perfect elliptical boundary of the skull, the central hollow ventricle system, the complex folds of the gyri and sulci. We need a hint for this one. The hint is, think about which part of the brain is famously known for its irregular, wrinkled appearance. Wrinkled. So it's not the skull. Ventricle. Yeah, the complex folds of the gyri and sulci. High frequency FBM perturbations are applied to the gray/white matter interface to simulate the irregular biological folding. We don't actually see it though. Folding of the brain surface. Don't actually see that. This simulation. That will be a future direction. Next question. When the simulate lesion control is toggled on, how is the resulting pathology characterized in the simulator visualization? And localized area increase acoustic pitch of increase acoustic. As a region with a rapid T1 relaxation similar to white matter, as low intensity perfectly spherical void with sharp edges, as a high density infiltrative zone with an edematous margin. I think it's D. Just kind of guess. Yeah, it's that bit. Lesions in the simulator exhibit prolonged relaxation profiles and altered spin density, causing them to appear bright and irregular. So that's that bit over there. Question 8. Which of the following identified as the future direction for modeling white diffusion? Incorporating an anisotropic diffusion tensor. It should be a hard quiz. Question 9. A simulator-based cerebrum envelope is identified by mathematical inequality. What does the term NX represent in the context? Just guess. Which resolution setting provides the finest anatomical? Yeah, it will be a 256. Yeah, high resolution matrices contain more voxels, allowing the sharper detail at the cost of significantly increased processing time. It doesn't make much difference in simulation though. Yeah, 64 and 28 to 56 is kind of the same. It's loading for longer, but other than that, there's not much difference. Yeah. And we actually tried to generate another audio, but it just gets stuck. Let's just go